So good afternoon. In this session, you're going to learn how to enable connectivity with VPNs and Direct Connect into your AWS resources. My goal is that in an hour's time, whether you're a network engineer, a cloud architect, new to the platform, or experienced with the platform, that you'll have all of the skills you need to get a connection up and running with AWS. My name is Steve Seymour. I'm a solutions architect. I'm based in the UK. There's going to be no use of the word router in this session. We'll be routing everything. OK, so what should you expect from this session? Well, I'm going to be talking about various scenarios that I see with customers that I work with regularly. So there's a bit of a story to this session. Within it, there's always going to be some characters to that story. So we have our network engineers, for example. Some locations, obviously the cloud is one of those. A corporate data center or a corporate network is the other component that I'm going to be talking about a lot during this session. And I hope to give you a toolbox, a set of things that you can use in the future when you're deploying connectivity projects relating to AWS. And finally, hopefully, a form of checklist and a set of methods that you can go through. So let's talk about the characters, the team that's involved in the examples we're going to be using this afternoon. First of all, we've got the network engineering team. Key, very important team in terms of a connectivity project, usually working very closely with a cloud architect team, perhaps the application developers as well. And the first thing I would say about establishing connectivity to AWS is it's key that those teams work together. There needs to be an understanding of what are the requirements from the network team, and what is it that the application owners, the architects, need from the solution. And then finally, I can't encourage you more to use the AWS Solutions Architecture team, the team that I'm part of, and our support team to help you with these projects. You can raise support cases to ask questions about, how do I do this? It doesn't have to be because you're having a problem with something. So this is going to be the basis of the discussion we're having on Amazon VPC. You've probably all got something deployed that's very similar to this, public subnets, private subnets, requirements for connectivity out to the internet. But we don't need to get into the detail of what's inside this particular VPC. So for this session, we're going to simplify that down to this. This is our VPC for the purpose of this discussion. On the corporate side, you've probably all seen network diagrams that look something like this. This is representative of the corporate infrastructure that we're going to be connecting into. Again, let's simplify that down for the purpose of this session. So this is our corporate infrastructure on the right of the screen. So that makes up our environment. We're going to be connecting these two together using VPNs, Direct Connect, and a few other topics that I'll touch on. So let's give ourselves a bit of room to work with. And we're going to fill in the gaps in the middle. OK, so what have we got in the toolbox that we're working with? Now, this is a 400-level session, so I'm going to assume that you all know what all these components are. And in fact, we're going to go one step further. We're not going to refer to them necessarily by their full names there. Let's use the short names that we use in the console. We don't tend to see route tables, though, shortened, so I'm going to leave that one as it is. But we're going to be referring to VPCs, VGWs, CGWs. DX is the abbreviation we use for Direct Connect. So these components make up the elements you need to establish connectivity into your VPC. The route tables send the traffic out of the VPC. The IGW is the way to get in and out to the internet. The VGW, the virtual gateway, gives you access to VPNs and Direct Connect endpoints. The VPN is the connectivity that you then use to connect to the customer gateway, and DX, Direct Connect, is the final part of the solution. So these are the four specific topics we're going to cover. The hardware VPN solution that we have, Direct Connect itself and virtual interfaces, how you deploy those on AWS, VPN Cloud Hub, which is something you may not have heard of, but has been around since we launched VPN. And then finally, I'm going to touch on some software VPN examples as well. So first of all, let's get straight into the hardware VPN solution that we have. So this is a pretty commonly accepted description of what IPsec is, taken straight from Wikipedia. But the things I want to focus on are the fact that it provides secure IP connectivity and communications. It authenticates and encrypts each and every IP packet using mutual authentication, in our case using a pre-shared key. And it enables the negotiation of cryptographic keys for exchanging the rest of the traffic over our VPN connection. So that's what we're going to be working with. That's the basis of the AWS hardware VPN solution. We have two slight variations of our VPN solution. We support both static or dynamic VPNs, and when we say dynamic, we mean BGP-based. That's going to be the focus of most of the discussion here, but I am going to talk a little bit about static VPNs first. In a static VPN situation, you need to specify the IP prefixes, the routes that you want to be routing traffic to. You put those into your route tables, and they're configured. You have to go in and manually change them, manually maintain them. However, a dynamic VPN uses BGP, Border Gateway Protocol. And we support 100 prefixes that you can announce to us over BGP. So that's dynamic. If you change them, they update inside AWS automatically. And then finally, BGP running over a VPN connection supports 2-byte AS numbers. So what we mean by that is we go from 1 through to 65535. The AWS VPN requirements. So these are all captured in the documentation, but there's a few important things I want to call out here. First of all, VPN connections to AWS are always initiated from the customer side. So your router needs to see interesting traffic and initiate the session to us. Secondly, we use pre-shared keys for authentication. When you create a VPN connection in the AWS console or via the APIs, we generate a pre-shared key that's used for the connection. We use IPsec SAs in tunnel mode, and that's important. I'll cover that in a little bit more detail in a moment. So we don't do policy-based VPNs. We use AES 128-bit encryption and SHA-1. We support DHPFS Group 2 and dead peer detection. And it's important to note that we require you to fragment IP packets before encryption. So even if they have the don't fragment header on them. OK, so this is our static VPN example. So back to the two environments that we have. On the left-hand side, we have our VPC. And I've just increased the size of the virtual private gateway there, because that's what we're focusing on. On the right-hand side, we have the corporate network. In a static VPN situation here, you have to specify which networks you want to route traffic to. And we support one unique SA per tunnel. So that's one inbound, one outbound, 2 unique pairs for 2 tunnels. So where did the 2 tunnels come from, you might ask? Well, when you configure a VPN with AWS, we actually configure 2 different endpoints on the AWS end in 2 different availability zones. So when you create that VPN, we actually give you the configuration details for 2 tunnels, and they come back to a single customer gateway on your side of that connection. We sometimes see customers with issues where they have certain types of hardware VPN device that every time they want to establish a new SA over their VPN, every time they want to route a different block of IP addresses over their VPN, it establishes a new SA. That's not going to work, because as I said on the previous slide, we only support 1 in each direction. So it's really important that you consolidate your ACLs to cover all of the traffic that you might want to route over this connection. Actually just announce it as a 0, an any connection. So at that point, you now control what traffic routes over this particular VPN using an access control list. So static VPN is slightly different. You do have to specify the IP addresses you want to route, and just remember that we only support that pair of SAs per tunnel. So let's move on to dynamic VPNs. So a little bit of level setting here. Some of you might have some experience with BGP, but I just want to recap quickly on that. So what is BGP? It's a TCP-based protocol, runs on port 179. It's a border gateway protocol. Within a BGP environment, you have BGP neighbors. They peer with each other, and they exchange routing information. They exchange prefixes. Now, a prefix is a combination of a CIDR block, a set of IP addresses, and an AS path. So what is an AS? An AS is an autonomous system, and it identifies different network environments. It's not individual devices. So for example, Amazon has a single large AS number that covers the whole of the Amazon network. You'll hear the terms iBGP and eBGP. So iBGP is where we establish a peering relationship between 2 neighbors that are in the same AS number, so used within usually the same network. eBGP is external BGP, as it says, between peers that are in different AS numbers. Finally, you're going to see some examples in the upcoming slides of an AS path. So this is a measure of network distance. Every time traffic passes from one network to the other, the AS number for that network is added to the AS path, and it gradually gets longer, which means when you're on the receiving end of a BGP announcement, you can see where did it come from, what path did it take. And if you have multiple announcements for multiple prefixes, you can see which one took a different path and perhaps make some decisions on which one is better. So that brings me finally to local preference. Now, you might have received 2 announcements for a particular prefix, and one of them looks a lot shorter and a lot more efficient to get to in terms of network. But actually, you may have much more bandwidth on another connection, or perhaps it's more cost-effective. So what local preference lets you do is enforce a choice at your end of the connection that no matter what the path length says or any of the other influencing factors or path decision elements, I'm going to choose this particular path. It's my local preference for sending traffic. So they're the components you're going to hear about in terms of BGP. So what does a dynamic VPN look like? Well, again, you'll recognize that it's pretty similar. It's still got 2 tunnels. So again, when you create the VPN configuration and choose that this is a dynamic BGP-based VPN, we'll configure 2 tunnels for you. You need to specify an IP address for each end of that tunnel. Now, when you're doing this over a VPN, we automatically generate those IP addresses for you in the configuration. On the AWS end, we have a fixed AS number. Generally, it's 7224, but it can vary by region. However, for your end, when you're configuring the VPN, you get to choose what AS number you want to use. Now, the thing about BGP, as I said, is it's dynamic. So as you announce routes over BGP into AWS, we need to do something with them. So we need to update the route table inside the VPC to specify how do we get to that remote network. So in this particular example, I'm actually just going to put an entry in there that specifies the corporate network on the right and to go via the virtual gateway. The virtual gateway then receives all of the BGP announcements from the corporate network. We do also have an option called route propagation as well. And what this does is it says, anything I receive at the virtual gateway via BGP, automatically put it into the route table for me. So now we don't have to maintain that route table manually. So BGP peer address is automatically generated. Your AS number, when you get to choose it, you can choose anything. So if you happen to have a public AS number for your network and you want to use that, that's fine. Otherwise, there's a block of AS numbers reserved for private use. The Amazon AS number, as I say, 7224 generally used. In a couple of regions, we have 9059 and 1 or 2 others. So always download the configuration that we generate and check what AS number we're using on the AWS side. So how does path selection work? The virtual gateway has now received its BGP announcements. How does it decide where it's sending its traffic? Well, first of all, we look for the most specific network announcement. So a /24 network is more preferable than a /16. So if we have the 2 of those in the route table, we'll pick the /24. Within the virtual gateway, we then have a look and see what have we got in terms of connections to a customer network, because they all come into the virtual gateway. If we see a static VPN connection, actually we prefer that first, because static routes come above any of the other route selections. Next, we choose Direct Connect. And then finally, we choose the shortest AS path. And it's actually down here that the dynamic VPN fits in. And that's very relevant because later on, if you have a Direct Connect in place, you're probably going to want to be using that for all of your traffic, except in a failover situation. So Direct Connect comes above dynamic VPN. So you might have noticed in the previous slides that we had 2 tunnels, but it came down to a single customer gateway on the corporate side. Obviously, a potential single point of failure there. So it's quite easy to just build 2 VPN connections, which in AWS terms mean that you've just created 4 tunnels. So now you have 4 resilient tunnels going into AWS, terminating in 2 different availability zones. And on the customer side, you have 2 customer gateway devices. These could be in the same data center, the same location, or they could be separate on your network. And you're probably going to have to run some sort of internal routing protocol between them to decide how do I route traffic to AWS. So that could be iBGP, to use the example from earlier, or OSPF, or whatever it is you deploy internally. This also then can extend onto connecting to multiple VPCs. So a single VPN connection only connects to a single VPC. So taking our resilient model where we had 2 customer gateways, 4 tunnels, we now have 2 VPCs on the left-hand side, and therefore we have 8 tunnels connected to them. All of these are dynamically routing to each other, all announcing their available prefixes back to the customer gateways. So this is when I just wanted to mention a recent update to the AWS VPN service. So we now support reusable customer gateway IP addresses. And what that means is that on your end of the VPN connection, you can use the same IP address in many of our regions now for connecting to multiple VPCs inside AWS. So this is rolling out across the regions at the moment. And it just means that you don't have to have a unique customer IP address for each gateway on your end of the connection. If this is something that you want to take advantage of, simply create a new virtual gateway, create a new VPN connection, then detach the old one from your VPC and attach the new one to it. Then, of course, delete the old virtual gateway and the old VPN connection to save cost. It's important to note you can only have a single virtual gateway attached to the VPC at any one time, so create the new one in parallel and then just swap them over. We are going to have some further features around VPN that are going to be announced in the coming months, so keep an eye on the forums and the blogs. So now let's step back to the beginning. How do you actually create this VPN connection? What does it look like? Well, there's 6 steps involved. First of all, you're going to create that virtual gateway. So you create this inside the AWS console, or obviously via the APIs. You give it a name. And at this point, it's not associated with anything. So the second step is you're going to attach it to your VPC. What is it we want to be able to route traffic to and from? The third step, we're going to define the other end of that VPN connection, the customer gateway. We specify the IP address, what type of routing we want to use, give it a name, etc. And if it's dynamic, specify the AS number that I mentioned earlier. Finally, we join those 2 components together, the virtual private gateway and the customer gateway, with a VPN. So at this point, you're simply choosing the 2 endpoints. And if you need to, you can create a new customer gateway here if you hadn't done it in the previous stage. But there's no other configuration you need to do. Once that's done, you go into your route tables, and if this is a dynamic VPN, simply enable route propagation. As you can see there, you check the box next to the virtual gateway. Now, anything that it receives over VPN or Direct Connect, as we're going to cover later, will automatically be propagated into that particular route table. So that's great. Everything's configured now on the AWS side. All that's left is to configure the customer end of this VPN connection. So you'll notice that we have a download configuration option. We provide configurations for a range of different router manufacturers, but we also have an option to download a generic configuration. This is standard IPsec VPN connectivity. So the information you need is within that generic configuration document, and you can use that to configure the equipment on your end of the connection. OK, so we're going to move on to Direct Connect now. So what is Direct Connect? Well, quite simply, it is a dedicated private link into the AWS network. You can create things called private or public virtual interfaces on a Direct Connect to give you access to different types of resources within the AWS environment. It enables you to benefit from reduced data transfer rates. Data transfer into AWS is always free, but reduced data transfer rates out of AWS. And one of the most common reasons for wanting to use Direct Connect is a combination between high bandwidth but consistent performance. So there's always going to be latency in a connection, but over a Direct Connect, it's going to be a consistent experience. It's going to be as low as we can make it, and it's coming directly into your network. It's avoiding any potential internet weather type events. So the VPN connection, as much bandwidth as you might have on your side and as much as there is on the AWS side, we are crossing the public internet. Direct Connect doesn't do that. There is at least one Direct Connect location for every AWS region. In many cases, there's multiple Direct Connect locations. And this is where you interface with our equipment to connect your fiber connection. You can have multiple Direct Connect connections. So you can establish multiple connections in one of our locations or across multiple locations for a particular region. And also, it's very common to see customers with multiple AWS accounts. So they might have perhaps a payer account, and then a development account, a test account, a production account. And they don't want to purchase a Direct Connect for every single one of those. Well, you can share a Direct Connect across those accounts. And then finally, we have something called inter-region connectivity, which is available within the US regions. And it enables you to get a connection at one particular US region and reach out to resources in another region. I'm going to talk about that in a little bit more detail later on. But it's for use with public virtual interfaces, for accessing things that are outside your VPC. And as we said earlier, all of this is using BGP to exchange routing information, and it's carrying that over an 802.1q VLAN that runs on Direct Connect. We don't support any other routing protocols at all over Direct Connect. It's specifically BGP, so no static routes, no OSPF. This is a list of the AWS regions and their corresponding Direct Connect locations. As you can see, many of them do actually have 2 Direct Connect locations. And these are colo facilities. These are places that you might actually have some of your own equipment or can at least get access to deploy equipment. This list is maintained and updated on the website, and we're always expanding these Direct Connect locations. So given that this is a network discussion, I thought somewhere in here I've got to get an OSI chart, so here we have it. Right at the bottom there, I've skipped a few of them, as you can see, but at the bottom we've got our physical layer, so layer 1. What is this in Direct Connect terms? Well, it's a single-mode fiber. For a 1 gig or a 10 gig Direct Connect, the physical layer is a single-mode fiber. So let's talk about the physical connection side of Direct Connect first. We've got a few terms up on the screen there. I'm sure they're familiar to most of you. Some of them have got something in common, which is that grouping are basically the same thing. They might be delivered in a slightly different way, but when it comes down to it, they're going to be either a layer 1 or a layer 2 Ethernet delivery of a service that extends the port from our location to wherever you're located. The bottom one is a little bit different. So how do we deploy the physical connection? Well, once you request a Direct Connect connection, we give you something called an LOA. I have an example of it later on, a letter of authority. And what it is permission to now connect to ports on AWS's routers. So if you're located within the same facility as our equipment, this can be as simple as a cross-connect under the floor. You can just raise a cross-connect request with, say, Equinix or CoreSite or one of our Direct Connect locations and say, here's our rack, here's where AWS are located, arrange a cross-connect for me. Single-mode fiber, as I said, the two interface types that we support, 1000 base LX and 10G base LR. If you're not within that facility, that goes back to those terms I was using earlier for the physical connections. So you might purchase a pseudo-wire type service or a LAN extension service from a carrier or a Direct Connect partner. And a Direct Connect partner will extend it from that location out to wherever you need it to be delivered to your equipment. And then the final component is obviously a router to go on the other end of that connection. So that router needs to support, obviously, the interface type. If it's within the building, that single-mode connection, or however the carrier presents it to you. It needs to support 802.1q VLANs, which is what we use to carry the BGP sessions. And this is what it looks like. So we've still got our same scenario here. Left-hand side is AWS, right-hand side is the corporate network. But we now have our Direct Connect location between us. We have the AWS Direct Connect routers in that location. And in this example, I'm showing that you're co-located there as well. So you've got perhaps some of your service, some infrastructure there, part of your environment you want to link into resources within AWS. You probably also have the rest of your customer network connecting back to the corporate environment on the right-hand side. So this is the really simple example I was talking about of a cross-connect. So what are the components that make up this? Well, first of all, between the AWS region and the Direct Connect location, we have the Amazon backbone. So this is the diverse and resilient connectivity from the Direct Connect location back to all of the availability zones within the AWS region. So Direct Connect gives you access to all of the availability zones. The next component here is the cross-connect that we've ordered perhaps from the facility between the AWS equipment and your equipment. Then we have your router, the customer router, perhaps sitting in your cage, your rack, an access circuit of some sort into a network, and then onward delivery into the corporate environment. So pretty standard, pretty simple deployment. The variation on this that I mentioned earlier was the partner delivery. So the Direct Connect partners, and there's a list of them on the website, they're very familiar with this process. And what you would do is you would hand them your letter of authority, which gives them permission to connect into the AWS equipment. They then connect it into their network and usually deliver it onto you as a layer 2 type connection. So now you still run the VLANs on your router, you still run the BGP. There are variations out there, but this is the most standard and the simplest model for a partner connection at 1 gig or 10 gig. So let's go back to that one that was slightly different. Let's talk about MPLS, IPVPN, VPLS, that type of thing. Well, in this scenario, you've usually got an existing network connecting together your corporate locations, perhaps a data center already. And these might be multiple locations globally. So on the edge of the MPLS network, there's going to be what's called PE equipment, provider edge, and you're going to have some CE routers, customer edge equipment inside your data centers. Now, in this particular case, if the carrier providing this connectivity for you is a Direct Connect partner, often they will take that LOA from you, order the cross-connect, and deliver it straight into their PE routers on the side of their MPLS network. They then encapsulate that and deliver it to your IPVPN or your layer 3 VPN service that you receive from them, but they do all of the BGP and the VLAN termination right at the edge in that location. So it's a slightly different deployment model. OK, let's go back to our model. I've removed the layer 1, 2, 3 and just put some of the terms in here that we use for Direct Connect and how they map onto the components on the right-hand side. So I've mentioned a virtual interface a couple of times. So what is that? Well, it sits on top of that physical connection we have at the very bottom of the stack here. So a virtual interface contains the VLAN definition. That's one of the components that we need to configure for Direct Connect. It contains the details of the IP addresses that we use on each end of the BGP session. And it carries the BGP session itself. So when you see the term virtual interface, that's what it means. So each virtual interface is a combination of a VLAN and a BGP session. All of that then enables you to route traffic, as it says at the top on the right-hand side. And if this is going to a VPC, so it's a private virtual interface, that's where it connects with the virtual private gateway and gives you access into your VPC. In this particular example, all of those components are owned by the same AWS account. So on the left-hand side, AC1. So let's talk about the difference between public and private virtual interfaces for a moment. What have they got in common? Well, they both use 8021Q VLANs. They both use eBGP, peering between two different AS numbers. As I said earlier, we accept 100 prefixes over BGP. But a private virtual interface is for accessing resources that are inside your virtual private cloud. So your EC2 resources that are running on IP addresses that you specified when you created the VPC. It doesn't give you access to VPC endpoints for S3 inside that VPC, and it doesn't enable any sort of transitive routing using VPC peering. It just gives you access to that particular VPC. So if you have multiple VPCs, you'll have multiple virtual interfaces, one going to each of them. A public virtual interface is used to access the services that are outside of your VPC, so things like DynamoDB, S3 public endpoints, SQS, any of those kinds of services that sit outside the VPC. If they're the things that you're using, then you're most likely to need a public virtual interface. So back to our model here. I wanted to just call out a couple of other terms that you might see or hear around Direct Connect. And this is identifying that we can separate out the ownership of the various components of Direct Connect. So the physical connection, perhaps that's owned by the network team. So it can sit in one particular AWS account. When you create a virtual interface, you can then choose to share that virtual interface to another account. And we then call that a hosted virtual interface. So now we have the separation there between two different accounts, perhaps the network team and the application owners. A further variation on that is where you're using one of our sub-1 gig connections. So these are bandwidths of 50 meg, 100, 234, and 500 megabits per second. These are not dedicated ports. These are ports that partners have connected with us already, and they provision the subrate connections for you on those ports. So in this particular case, the partner already has the physical connection. In this case, we call it an interconnect. You speak with that partner about what connectivity you require, how much bandwidth do you need, and they will then provision you what's called a hosted connection on that interconnect. They specify the bandwidth, and because they own the physical connection, they choose the VLAN tag that's going to be used for it. But at that point, it's presented into your account, into your customer account, and we call that a hosted connection. From this point up, it's exactly the same as the other types of dedicated port connections. You still create a virtual interface, and you still attach it to a virtual private gateway. There's one slight difference here in that it only supports a single virtual interface per hosted connection. So if you need to connect to multiple VPCs, simply have a conversation with the Direct Connect partner that says, I might need 2 or 3 hosted connections to put a virtual interface on each one of them. Just to add one more layer of complexity in here, you still have the option to create a hosted virtual interface in this model. So the partner has now created the hosted connection and shared it with perhaps your main account. Within that main account, you've then created a virtual interface, and you've shared that to the development team. So it's now a hosted virtual interface. So we now have 3 elements involved, 3 owners of the different components of Direct Connect. So as I say, it only provides access to resources within the VPC. It attaches at that same place that the VPN connections do. So it comes into the virtual private gateway. And that's relevant for Cloud Hub, which we'll be talking about towards the end. You can attach multiple private VIFs, virtual interfaces, to that virtual private gateway. So if there's multiple connections, you simply attach multiple virtual interfaces to that virtual private gateway. And because this is a private virtual interface, you can use whatever IP addresses you like. So you can specify the IP addresses for the peering session, or we'll automatically generate them for you. You can announce any IP addresses you like over that BGP session to us, we'll then propagate them into your route table. You can also just announce a default route. So at that point, we'll send all traffic out via the virtual gateway back to your corporate network. So what does that look like when we deploy it into our environment? Back to our VPC and our corporate data center on the right-hand side, you can see the parameters at the very top. So the first thing is a virtual interface. We identify it by something called a DX VIF identifier. You'll see that in the console. On the custom side, it's usually identified by some sort of sub-interface or VLAN definition on your equipment. We choose a VLAN tag. We did that via the console earlier. We're going to specify the IP addresses that we use for that peering session. The AS number, again, on the AWS side, that's fixed. Generally the same for most regions, but there is some variation. On the customer side, you get to choose what AS number you want to use. So as I said earlier, you can choose anything you like. This is a private virtual interface. Underneath all of that, there's then an MD5 key that's used for authentication between the two BGP peers. And the end result of this is that we now have an eBGP session up and running between AWS and your equipment. From the AWS side, what are we going to be announcing? Well, it's quite simple. It's the CIDR block for your VPC. It will be a single prefix announcement. We don't announce individual subnets, and it will be just that VPC that you attached the virtual interface to. On your side, as I said, you can announce anything to us. Generally, it would be the corporate addresses, but it could be a default route. But either way, you still need to go into the route table inside your VPC and either turn on route propagation or put a static route in there. This is exactly the same as we did for the VPN connection earlier. So let's go back to the physical deployment that we had. You recall earlier where we'd broken down the various components that make up the connection. And obviously, you could have two connections. Now, if you request two direct connect connections via the AWS console, we will automatically provision those for you on different equipment on the AWS side. So at this point, you've got hardware resilience and redundancy. It's coming into the same physical router on your side in this particular scenario, but then onward into your network to provide that connectivity. So what does this look like? If we have two physical connections, what do we now do with the virtual interfaces? Well, each of those physical connections is treated independently. So we're going to configure two virtual interfaces, two private VIFs in this case. All the same parameters that we had before, but there's two of them. One thing I want to draw attention to here, though, is that because we're attaching these virtual interfaces to the same VPC, we need to make sure that we're using different IP addresses for the peering. You can, however, use the same VLAN. And that's because the VLAN is just contained to that one particular physical connection. It's used to separate out each of the virtual interfaces. But beyond that, it doesn't get carried into the AWS network at all. So for simplicity, we quite often see customers creating virtual interfaces with the same VLAN number on each of their connections if they're going to the same place. So going back to the physical infrastructure again, obviously this kind of gives you a level of resilience. You now have two connections from AWS, but actually it would be much better if we simply did that. So let's have two customer routers. So the same configuration applies here. There's no difference in terms of how you deploy this. But it is a really simple solution. But a variation on that, again, if you want a level of resilience that is geographically diverse, is to move those two routers on your side into different direct connect locations. So here I'm showing a region that has two direct connect locations. So two separate sets of direct connect routers going to two separate customer gateway devices, and then on via a service provider into your network. But if we've gone this far, well, we can simply do that as well. So now we have 4 direct connect connections. The point I'm making is that you can layer as much resiliency into the solution as you like. We give you the options to do this. And each time you do, you then just create virtual interfaces on top of the physical connections to carry that traffic to your resources on the AWS side. And in reality, a combination of these scenarios are used by many customers. So we've got our 2 virtual interfaces up and running. Let's keep a fairly simple scenario, just 2 connections. Well, what does that look like? Well, if you've got 2 virtual interfaces, you probably want to be running them in an active-active configuration. And by default, if these came into the same router, what would happen is your router would make a decision of which one it prefers based on a certain algorithm, and that would be where it sends all the traffic. You can quite simply update that to use BGP multipath. So the example here is a Cisco router. By adding 1 extra configuration option, maximum paths 2, the M will appear next to those particular routes in the route table, which means you'll now be multipathing across them. effectively network-level load balancing, if you like. So now you're getting the benefit of both physical connections. If we look at it, though, from the perspective of the virtual gateway, it's received those announcements from you. What's it going to do with them? It's received the same thing twice. Well, we automatically assume, therefore, that you want to run this as active-active, and that you would like us to also do multipath. So we can see these two identical paths via two different peers. Perfect. We'll do multipath for you. This is not a configuration or option or anything that you do in the console. It's what we choose by default. What if you don't want to run active-active, though? So what if on your side these connections go to perhaps two different data centers and you run active standby or a hot-cold setup? Well, in that case, you're going to want to choose one particular connection over the other, and you probably want to actively decide which one you want to prefer. So this is where that local preference thing comes in that I mentioned earlier. In your configuration, you specify that as you receive these routes from us, you apply a local preference to them. The higher the preference, the more preferred route. So in this case, the bottom example, 200, that's the one that we're going to be using. And you can see that indicated by the chevron on the left-hand side. So that's our preferred path from the customer side. But what about on the virtual gateway side? Well, we haven't changed anything, so it's still the same AS path length. We're still going to be doing BGP multipath. So you're going to be sending traffic over one connection. We're going to reply by sending traffic over both of them. And that's probably not what you wanted to achieve. Well, we give you the ability to influence that choice. And you do this using AS path prepending. So what you do here is you artificially make us believe that one of those connections is slightly longer in terms of network distance than the other. So in this case, I have two examples. We're doing AS prepending ×2 and ×1, where we put our AS number on the path a couple of times before we pass it on to the AWS routers. So now we look at that from the virtual gateway perspective, and one of these paths looks longer than the other. So we now make a path selection, and we choose the shortest path. So at this point, you've influenced our choice of whether we're doing active-passive or active-active. There's no configuration that you need to do in the console for this. This is all controlled from your customer device where you're announcing these routes. So let's move on and talk about a public virtual interface over Direct Connect. So it provides access to Amazon's public IP addresses. So this is all of the public IP addresses for that particular AWS region, everything that's running there. That includes things like S3. It could include other services that are running on AWS. It could include the Amazon retail site. When you set up a BGP session for a public virtual interface, there are a few different requirements, though, compared to a private virtual interface. We require you to use public IP addresses on a public virtual interface. So if you've got your own IP addresses that you can use for this peering session, and you're going to announce public IP addresses to us, great. Nothing else needs to happen. You just configure it in the console, and I'll show you what that looks like. If, however, you don't have public IP addresses that you own, or you aren't able to break up your network to be able to use those on a BGP session with AWS, then raise a case with AWS support. We'll actually issue you a /31, so 2 IP addresses that you can use for this BGP peering session, at which point you can NAT behind that on your end of the connection to reach all of these services. So simply raise a case with AWS support if that's something you need for a public virtual interface. The AS number that you use on the public virtual interface. If you're going to use a public AS number, you will need to own that AS. And we go through a verification process when you set up a public virtual interface where we validate the ownership of the IP addresses and the AS number that you've used when configuring it. If you don't have a public AS number, that's fine. You can use a private AS number. Finally, this inter-region feature that's available within the US. So what is it? Well, quite simply, a Direct Connect location is associated with one particular region. So a private virtual interface gives us access to the VPCs within that region. Public virtual interface, access to the public services within that region. Within the US, however, we actually announce all of the public IP addresses from all of the US regions at any of our Direct Connect locations. So that means you could get a connection on the West Coast, but actually be accessing services on the East Coast, all through that single connection. We recently announced that we've added BGP communities to these announcements. So this was posted on the forum last week. And what this means is that when you look at the prefixes we announced to you, you can now identify where they came from. So if you see the 8100 community tagged on a particular prefix, you know that that came from the local AWS region to which you're connected. If it's got 8200 on it, it came from somewhere within the continent, from one of the other regions. And equally, for traffic engineering purposes on your side, you might not want us to propagate your routes beyond the local region. So as you announce them into our network, we look at the communities that you tag them with as well. So if you tag them with 9100, then we'll keep them to just the local AWS region. If you tag them with 9200, they'll go to all of the AWS regions. And that's the default position within the US. So what does a public virtual interface look like in our configuration? Well, exactly all of the same parameters we talked about for a private virtual interface at the top there. It's got a DX VIF identifier, a VLAN, IP addresses for the BGP session. It's got an AS number, both sides, and an MD5 key. But you're going to see a slightly different announcement from the AWS side. It's not a single prefix now. It's going to be all of those prefixes I talked about. And these vary over time. So you might be aware that we actually publish a list of all of the Amazon IP addresses via an ipranges.json file that you can use to download and compare against this list if you need to. On the customer side, though, you can announce to us whatever public IP addresses you want us to route to. And this impacts all traffic that leaves that particular AWS region. That's why we go through the verification process to check that you own them. That process takes a maximum of 72 hours, usually a much shorter time. And if you've used those IP addresses with us before, it will go through much more of an automatic process. But you can announce those IP addresses to us, and now all traffic leaving the Amazon network destined for those IP addresses will go over this public virtual interface rather than over the internet. Here's an example of the output, again, on a Cisco router in this particular case. And you can see the AS path on the right-hand side. You'll notice that 7224, which is the one we use for Direct Connect, is present on all of them. But then beyond that, you see another one. And 16509 is the Amazon global AS number. So we use 7224 just for Direct Connect, and then you're going to see the other Amazon AS numbers beyond that for some of the prefixes. As a community example, here's a particular announcement that's coming over BGP where it's showing that it's tagged with the 8100 and the 8200 community. So this is showing that it's an inter-region prefix and that it's coming from outside of the local AWS region. So how do we actually deploy all of this? How do we order it? What does it look like? Well, here are the steps. And the very first important one is make sure you choose the correct region. Ordering a connection in the wrong region might give you a few problems. If you do, just to be clear, just delete the connection as soon as you've created it. It's not a problem. Choose the region you want the connection in. The reason that's important is when you go to actually create the connection in the Direct Connect console, we then populate a list of the Direct Connect locations. And obviously, they're tied to that particular region. You then choose the amount of bandwidth you need, and that's it. That's your Direct Connect connection requested. We will then send you by email an LOA CFA, Letter of Authority Connecting Facility Agreement. It's a document that says you have permission to, excuse me, you have permission to connect to these ports on the AWS routers. You're going to be using this with the facility provider to order that cross-connect, or with the partner if they're going to be providing connectivity. The LOA CFA is sent to the root email address of the account that requested the connection. So make sure that you are monitoring the email account for that particular address. Once you've received the LOA, you then need to order the cross-connect. In our documentation, we actually provide a list of the locations and what the process is for that particular provider. Some of them require this by email. Some of them have an online portal that you upload the LOA to. So just follow their process to order the cross-connect, or a partner will be doing it on your behalf. Once you've done that, you're then able to configure your virtual interfaces. Now, you can actually do this before the physical connection even comes up. So once you've ordered it, you've ordered the cross-connect, start configuring the virtual interfaces. At the very, very top of the screen is the decision as to whether this is a public or a private virtual interface. Once you make that decision, the form then updates below that to change some of the fields to match the items I was talking about earlier. So now you fill in the details, you're going to name this connection, and you can see there that the virtual interface owner is one of the options you've got. So you can share this virtual interface into another AWS account, as per the examples we had on the screen earlier. Once that's done, just like in the VPN configuration scenario, we give you the option to download a router configuration. Now, it's a very basic configuration, but it contains all the information you need for your end of the connection. So it'll contain the IP addresses for the peering session, the AS number being used by Amazon, the MD5 key that you either chose or that you generated, and all of the other details you need for configuring that connection. So that's if you're ordering a 1 or a 10 gig dedicated port. The process if you're doing this through a partner for one of those sub 1 gig connections is slightly different. It's actually initiated by the partner. So you're going to give your AWS account number to the partner. This is your 12-digit AWS account number. And you're going to have a discussion with them about how much bandwidth you need. The partner is then going to configure that as a hosted connection for you. And you'll go into your account and simply accept that hosted connection. It appears in the same Direct Connect console where you would have requested your own dedicated port. Once you've accepted that connection, we're then back into the standard flow that we were following earlier. Configure a virtual interface, configure our router. So there's no difference once you've accepted that connection. But remember, you can only create a single virtual interface on that hosted connection. OK, now, depending on how much resilience you've put into your solution, you might have 2 connections going to 2 different Direct Connect locations. We'd still always recommend that you put a VPN in place. Maintenance still might need to be done by your carriers, your partners. You might need to replace a router. It's always good to have another backup in place. So you can configure this VPN as a dynamic BGP-based VPN, as we talked about earlier, in exactly the same way in parallel to Direct Connect. We talked about the fact that from the AWS side, if we see multiple ways out of a virtual gateway going via Direct Connect and via VPN, we'll always prefer the Direct Connects first. After that, we then fail over back to the VPNs. And you would need to configure the same on your side so that you make path selections there. One other interesting variation of running a VPN with Direct Connect is to actually run it over the top of a Direct Connect. So if you wanted an encrypted connection into your VPC, or perhaps you wanted to reach a VPC that is in a remote AWS region. So in the US, you might have your Direct Connect on the West Coast, and you're running your VPC on the East Coast. Or perhaps you'd establish a VPN over that public virtual interface, because within the announcements for all of the Amazon public IP addresses are the endpoints for those VPN connections as well. So now you can take advantage of the Direct Connect that you have already on one coast and connect to resources on the other coast, running over the Amazon backbone network. So you can see the components here that you'd have to configure to do that. You've got the public virtual interface at the top of the screen, all the parameters that we had before. And then running over the top of that, we have our 2 tunnels for the VPN connection, again running BGP. So you then need to accept those onto your router and configure it appropriately to route to the different VPCs on the AWS side. Now, I just wanted to touch on billing for both of these services. So VPN connections, pretty simple. There are charges for each connection hour that your connection is present, and then we charge for data transfer at our standard internet rates. On Direct Connect, we charge for port hours. So this is a charge from the moment that your port goes active. So when you first order that port, we know that it's going to take a bit of time to organize that cross-connect and to work with a partner perhaps to get that connection to your facility. So we don't start charging you for that port until it comes up for the first time, or if 90 days have expired, whichever comes sooner. Over a Direct Connect, you benefit from the reduced data transfer charges. And one thing I wanted to identify here was that you don't pay for data transfer when you're accessing resources that are owned by other accounts. So if you're downloading content from my S3 bucket, you don't pay for that data transfer over Direct Connect. You only pay for data transfer from your own resources. And finally, if you're running a VPN over the top of Direct Connect, in the scenario that was on the previous slide, that gets charged for at the reduced rate for Direct Connect, not at the internet data transfer rates. So a few things to remember around Direct Connect. It's one of our services that has that physical component to it. So although you interact with it via the APIs and via the console, the end result is a physical port that you need to connect to. So these ports are all at third-party data centers. These are not Amazon data centers. And they're there because we want you to be able to access them. You're going to have to work with at least one other organization to achieve this connectivity. If you're within the facility, it's going to be the co-location provider. It could be a network provider or a Direct Connect partner. Or it could be a combination of multiple if you're going to do connections to multiple facilities. So it's always going to involve a third party. Sub 1 gig connections only support single virtual interfaces. But that's quite easy to overcome. If you need multiple, you just request multiple hosted connections and run a VIF over each one of them. You can share virtual interfaces with other accounts. So just because the physical connection lives in one account, you can use it within another one. And finally, remember that the public virtual interfaces do include the hardware VPN endpoints that you can use for a BGP or static-based VPN. This is just an example of an implementation plan for Direct Connect. And the reason I've put it up here is because of those third-party engagements that are required usually for deploying Direct Connect, I'd recommend that you do treat it as a mini project. So put together a plan, establish who should be doing what, standard project planning, and then stick to it. Work through that process. You might have some complications along the way with perhaps carriers arranging connections, but if you have something that everyone is referring to as the steps that are required, this is something that's going to really help you succeed with the connection. OK, so just winding up, we're going to talk about the Cloud Hub functionality that we have. So within a virtual gateway, if you have multiple connections, be they over a VPN or virtual interfaces over Direct Connect, if we see multiple connections all coming from different AS numbers in BGP terms, we'll actually route between them for you. We'll act as a hub to a hub-and-spoke network. So this is not something that you go and turn on or turn off. It's default functionality within the virtual gateway. So at this point, we can provide that connectivity between your different locations, if that's something that you want. Some customers use it as a backup and have their own network linking their sites together. One other common deployment that we see is customers choose to deploy their own VPN solution. Perhaps they have an established software solution that they use already. We have many on the AWS Marketplace, so the Cisco CSR, the Sophos UTM. There's various open source options, such as OpenSwan, BIOS, things like that. So you can deploy a software VPN within your VPC. Of course, in this case, it doesn't go via the virtual private gateway. It comes in through the internet gateway and terminates on that EC2 instance. You also do need to consider high availability if you deploy a solution like this, though. So certainly make sure you deploy at least 2 VPN instances into 2 different availability zones and have appropriate health checking and failover between them. One final interesting scenario is to combine those 2 things together. So we can take Cloud Hub and a software VPN running in another AWS region, connect the 2 together, and provide access via Direct Connect or VPN from the other locations. So let me explain that in a little bit more detail. Down on the bottom right there, we've got one of your office locations, perhaps. It might have a Direct Connect into the virtual private gateway, and it's receiving a BGP announcement for the VPC in US East 1 in this example. If you then deployed a software VPN solution into EU Central 1, perhaps, and established a VPN from those software instances to the same virtual gateway in US East, the prefixes now that are going to be announced from that VPC in EU Central are actually going to be propagated by the virtual gateway to you over that Direct Connect. So you're now actually benefiting from a single connection, or in this case, 2 office connections into AWS, and able to route via the virtual private gateway to a VPC in another region. So just to recap the topics that we covered there. We talked about VPNs, both static and dynamic. How can we achieve connectivity using AWS Direct Connect via both public and private virtual interfaces? Cloud Hub and software VPNs, how you can use them together. And then finally, hopefully I've given you an insight into some of the steps required to configure all of these elements. With that, I'd like to say thank you very much, and I'd really appreciate it if you could complete the session evaluations. Thank you.